Welcome to Brain Vision.
We're told that we have a wavelength, lambda, of 70 picometers, and we want to know the minimum acceleration voltage required to produce an X-ray when the starting wavelength is that lambda value. So the equation for the shortest wavelength that can produce an X-ray is lambda is equal to 1,240 nanometer times volts per delta V, where delta V is the minimum voltage required to produce this X-ray. So we just rearrange this to solve for delta V, but we notice in our numerator we have units of nanometers times volt. We want to get to units of volts, so we need to cancel out that units of nanometers. So we need to convert our wavelength from picometers to nanometers. Well, there are 10 to the minus 3 picometers in every 1 nanometer. So this would be 70 times 10 to the minus 3 nanometers. Another way of saying this is a picometer is 10 to the minus 12 meters, and a nanometer is 10 to the minus 9 meters. So that's how you can think about this conversion. So we have 70 times 10 to the minus 3 nanometers. So rearranging this equation to solve for delta V, we find delta V is equal to 1,240 nanometer volts divided by our wavelength. So now you see that the nanometers are going to cancel out, and we're going to be left with units of just volts, which is what we want. And this comes out to equal 17.7 times 10 to the third volts, or 17.7 kilovolts. So you can write it as 17.7 times 10 to the third volts, or 17.7 kilovolts. Either way, it's the correct answer, and we can box it in.